Welcome back to FE Test Prep. This is going to be the first introductory video into our first subcategory, which is going to be statics. Statics is the study of forces at rest, which means the net forces acting on the object or whatever the subject is going to be zero. So the first and biggest portion of statics is going to be the forces and moments. So if there's nothing else that you remember about statics, it's that in every statics problem, the sum of the forces, which is what we got right here, the sum, let me get this marker, the sum of the forces is going to be zero. Like we said, zero forces. This is the sum, right? So F net. And we'll break this down. There's a couple of different ways to look at that as well. We have to break it down into directions because the forces will be summed up. The next thing is the moments. And a moment is basically it's a result of a force applied at a distance from a particular axis. So when you take a wrench and you attach it onto a bolt and you turn it, you are applying a moment to that bolt. It is rotating with the force that you are using on a lever arm. So moments allow us to apply leverage and get a greater mechanical outcome than if I just stuck my hand on the bolt and tried to turn it with my hand. And so in every statics problem, not only will the forces have to be zero, but also the moments have to be zero. Some of the moments have to be zero. That's what this sigma sign means right here, is summation, right? And if the moments aren't zero, guess what? The object is going to start turning. It's going to start bending. It's going to start doing something. So same thing if the summation of the forces aren't zero, the object is going to start accelerating. If the moment isn't zero, the object is going to start turning. And so in every statics problem, that is the first thing that you look at. Some of the forces zero, some of the moments zero. All right, and so force equals, a lot of times in these problems, they'll just give us the force, to be honest. And a lot of times it's in newtons for the FE, so SI units. But just for clarity, we're going to say force is equal to mass times acceleration. And in our problems, the only acceleration that we're concerned about is gravity. So this is really going to be mass times gravitational constant. In our case, the gravitational constant is going to be 9.81 meters per second squared. Remember it. Get a tattoo of it. Do not forget it. 9.81 meters per second squared. So, super easy. All you have to do is find the problem, figure out what the mass is. They'll give you the mass. A lot of times, like I said, they'll give you the force, and then multiply it by the gravitational constant, and you've got the force. And the reason the forces are important is you've got to use the forces for the moments as well. So a moment is going to be equal to a force times a distance, or a force times a radius. And in particular, this distance or radius is from the axis of rotation. It's not just any distance, it's not just any radius, it's perpendicular to the force applied. So if I've got, let me just do an example here with a bolt. I've got a bolt here, and I've got some kind of a wrench around it. I apply a force here, F. This is my moment arm right here. This is my force for the moment, and this is my moment arm, right? So this bolt is going to want to turn this way, and in the statics problem, we have to say, okay, what is the amount of torque or the moment being applied in the opposite direction such that this bolt does not move? So we will do additional problems related to figuring out what the moment arm is. Last thing I'll say is these forces and moments are typically broken down into axes. And a lot of times in these problems, we'll just deal in two planes, right? So in the real world, to simplify it, I guess we're in a three-dimensional world, right? We're not going to try to complicate this with any crazy modern physics nonsense or anything like that. Like 3 dimensions, right? So X plane, Y plane, Z plane, in and out of the lens of this camera right here, in and out, me looking at you, that's a Z plane. So most of the time on these problems, you'll just be in 2 planes, an X and a Y. So you'll have to break the forces down into the sum of the forces. So this subset of this will be sum of the forces about the X will equal 0, and the sum of the forces about the Y-axis will equal 0. And the purpose of this is to basically simplify the problem. It's much, yes, you have to make sure that the forces are opposite and opposing, otherwise you'll never be able to sum them appropriately. So that's why you break it down into X and Y, and like I said, sometimes you will have sum of the forces in the Z equals 0, and it's going to be the same exact case for our moment. The moment is going to be, we can basically sub all of this out, all these F's right here out, with M's. So sum of the moment about the X, sum of the moment about the Y, sum of the moment about the Z is 0. One thing you're going to want to also learn is going to be our right-hand rule. So in order to understand the axis of rotation for the moment, you're going to want to know how to do the right-hand rule. So in this particular instance right here, we've got a force down. So typically I take the hand. The hand goes in the direction of the force. The fingers curl in the direction of the moment arm. So I'll go down and then curl towards me, and then the thumb points in the direction of moment axis. So this is rotating about this axis, and since it's into the board, we're going to call it the Z axis. So in this particular case, the moment is about the Z, and typically into the board is negative, and conventionally, as long as you keep your directions consistent, it doesn't really matter for the problems, but typically for me, into the board is going to be negative, out of the board is going to be positive, and so this is going to be a positive moment about the Z-axis, right? And then the bolt will have to apply this will be a negative. Negative, into the board is negative. The bolt will have to apply a positive moment about the Z-axis in order to counteract the negative moment that we are applying with this force. So again, the right-hand rule is fingers. So at this point I royally screwed up the right-hand rule, but the principle is the same. Basically, fingers are going to be in the direction of the moment arm, and then curl the fingers in the direction of the force. So essentially, your hand is going to rotate in the direction in which the object is trying to curl or rotate, and then the thumb is going to point in the axis of rotation. So here I got it backwards, but that's what the correct is, and we should have an illustration on the screen. So this is how you'll figure out all the moments, except for in beams. There's some oddities, but we'll get to that when we cross that bridge. No pun intended with statics. Anyways, that is essentially all you need to know. Just to wrap it up, we've got sum of the forces are 0, sum of the moments are 0, right? The objects are not moving. The forces in most of these problems are just going to be the mass times gravity, and like I said, a lot of these they'll give you the force, so you don't even have to solve for it. A lot of times it'll just say, hey, 100 Newton force is applied. The moments are going to be the force times the axis that the moment is applied about, force times distance or force times the radius, depending on what you're looking at. And that's it, right hand rule. All right, thanks for watching. We'll see you in the next one.